phase, the gas phase filtration industry for about a little over 20 years or so. So looking forward to today's topic, where we're going to discuss the corrosion protection for mission critical electronics in the Middle East. So with that said, we'll go ahead and get started. So just here's the table of contents of kind of what we're going to discuss in this presentation. For any attendees that have previously joined our webinar services, some of this information may be may have heard previously, but so this will be a great refresher. But for all that are new, welcome, and I hope this information is very informative. Just a little bit about this brief introduction about PureAir filtration, and what sets us apart from our competition. We are a single source manufacturer for gas phase filtration systems, the media, and monitoring as well. So we can actually design the systems and determine the best media to use for each application, as each application is very unique. We're also ISO 9001 certified company, so that will guarantee that the quality of our systems and media will be excellent. We're also providing customized solutions for unique applications. So not just providing those cookie cutter solutions where one size fits all. No, we actually take a look at each project individually and come up with the best possible solution. We have a world-class laboratory here for monitoring, testing different medias, also developing new medias, and determining what medias are best for each application. And we do that with, we have in-house PhDs in chemical engineering, and we provide that research to make sure we provide solution. We also can monitor absorbent medias in the field as well. So talk about that a little later in this presentation. So what is gas phase filtration? Well, first, I want to just talk about the types of filtration. So you have mechanical filtration, where removing solids in the air, whether it's dust or smoke, also liquids in the form of mist. So similar to what you would see in like a air handler or some type of furnace filter. For our systems, we're going to focus on gas phase filtration. This can kind of give you a kind of general size. A micron equals a micrometer, or 1/1,000,000th of a meter. So for the systems we're going to talk about is what is gas phase filtration. And gas phase filtration is the removal of harmful and nuisance and toxic gases from the air. So with gas phase filtration, it's the process of utilizing specialized filter media and chemical substances to remove gaseous pollutants from the airstream. And in most cases, in most gas phase filtration systems, a substance called a sorbent is used to literally absorb the chemical substance and remove them from the indoor air. It's one to give you can see the size of gases, whether it's 0.0003 microns to 0.007. Just to give you a comparison, human hair is about 100 microns. That kind of gives you an idea of how small these molecules are when it comes to gases. So some of the, like I said, again, removing those molecules of gas from the air, some of the common gases removed are hydrogen sulfide, sulfur dioxide, chlorine, ammonia, and other VOCs as well. And here in this illustration shows in a typical chemical filter, the chemical is really the illustration of how the odorous or contaminated air passes through the absorbent media and how it's purified. So in the direction of airflow, you have the contaminated air. In this section, you have media that's already used up and already spent. And this active transfer zone, or they call it the working zone, that's the area that's actually doing the work for removing the contaminants from the airstream. So that active transfer zone is just making its way, progressing in the direction of airflow until the entire bed of media is used up. And here you have the unused media and purified air. This is very important for us when it comes to monitoring absorbent media life. So And again, in different adsorbents will be used for different gases. It really just depends on what's in the what the project requires, what's in the airstream. So adsorption, typically the medias for that are activated carbon. So it's, activated carbons are very porous. So as those gaseous molecules enter into the, come in contact with the media, it just holds, it gets trapped in those pores and is held in place. Great for removing, some larger molecules. But this process is reversible. So in some cases, some customers will use reactivated carbons, where you use some process to remove those gaseous molecules from the carbon itself. Chemical absorption or chemisorption. So that's this process is specific and is dependent on the neutralizing chemical and both the adsorbent and the gas being absorbed. So the chemical oxidation converts the corrosive gases to inoffensive solids. So of the exhausted media, so management. So it turns it into a harmless byproduct to be disposed like ordinary waste. It's non-toxic. And some of those different medias, in essence, you have some type of a substrate, and it's impregnated with the catalyst that will react with that gas and turn it into a harmless byproduct. And this process is permanent, so you cannot reverse it. So once that media is used up, you have to dispose of it and replace it with new media. So carbon versus PureAir are engineered medias. So carbon, like as I mentioned, is a highly porous substance that attracts and holds organic chemicals inside it. Has great surface area with a great internal pore structure network that kind of results in that like a large surface area for the different gases and molecules to be trapped inside. The only problem with carbon, it's not UL certified, so it can catch on fire, and in some cases it has. And there's really no method to determine the remaining media life of activated carbon. So there's, really the only method is once you have the contaminated gas breaking through, then that's when you realize that it's time to replace the carbon. With engineered medias, it is UL certifiable. Typically, there's no issues of catching fire. There are methods to measure the remaining media life. And it's also when that media is used up, it is non-hazardous. And as I mentioned, we can, with our lab, our world-class laboratory, we can test the remaining media life and majority of our engineered absorbents. Here's just a slide, some of the different medias that we use, depending on the application. So when it comes to some of the activated carbons, we have our PureAir ACX. So it's an extruded activated carbon. Really has become like a standard over the past few decades, and it's very low cost but very effective. Pure ACC, which is a coconut shell-based carbon, which is really considered, some of the finest in the world, for air purification, but it has a much higher pressure drop. So really depends on the application and what we can provide or what makes the most sense. On the engineered absorbents, we manufacture those medias first using different substrates, whether it's activated carbon, aluminum oxide or alumina, zeolites, clays for the substrate. And we also, then from there, we have the impregnates, for that media, whether it's some caustics, acids, or oxidizers or catalysts, which is used to remove the different gases that may be present in the airstream. Now, for oil and gas applications, we've had some great success using a blend of KOH impregnated carbon and potassium permanganate. It's called our PP blend media. So the PP blend is a very broad acting media, and they'll remove about 99% of different gases. So very effective solution if you have a broad range of different gases. And also one of the benefits of that media is that it has a color change component, because the permanganate-based media, the purple pellet, will actually change to a white, go from brown to white once it's used up. So that also gives the end users an ability to determine when it's time to change out the media. We also have carbon impregnated different pleated type filters. These can be, you can definitely provide the gas phase filtration, but at the higher velocity. So these filters can be installed in air handlers if you need that, some type of filtration. But most likely in applications where the gas levels will be very low. These might be a solution to provide some temporary gas phase filtration if needed. And two different media types that we can bond to these filters: activated carbon, as well as a blended media, which activated carbon and potassium permanganate. Now, matrix filters, very similar to the pleated filters in that you can size these to fit into existing air handlers. But these filters actually, they contain a lot more media and are much more efficient. So, and they have a very, very low pressure drop. So you can run these filters at 500 feet per minute, like a pleated filter, and you can still achieve about 99% removal efficiency of particular gases. So, and with these matrix filter structured media blocks, we can actually design them for ammonia removal, as well as quite a few acid gases, and without creating any dust. All right, on the air scrubbing equipment, as I mentioned in the second slide, what kind of sets PureAir apart is that we can provide customized solutions for just about any application. So systems can come in varying sizes, various configurations, and using that dry scrubbing gas phase technology. So we talk about modular units. So they use the disposable modules filled with that specific engineered adsorbent media. So once that media is spent, the module can be removed, disposed of, and replaced. Modular units also accommodate higher velocities. So you can provide those systems with velocities 250 feet per minute, or either 500 feet per minute. It depends on the level of contaminants and also space restrictions, or different requirements or restrictions, footprint restrictions. So deep bed units, they have a much higher amount or volume of media per system. So great for removing high levels of contaminants. The only downside with the deep bed systems, they will have a higher cost than a modular system, and also the maximum velocity through the deep bed system is only about 100 feet per minute. So you need a much bigger unit. Depending on the contaminant level. We'll be using deep bed units on a project in Saudi Arabia. It's called Marjan 10. I'll talk about that a little later here in the presentation. So, industries and applications for PureAir filtration. So the previous slide was just kind of a brief introduction to our capabilities and kind of the industries we work in. So here are the four main industries that require the gas phase filtration. So you have odor and environmental emission control, which that's mostly wastewater applications, whether it's municipal or industrial. So we're going to make sure we eliminate different odors before they escape these different plants. Nuisance odors before they escape plants, causing complaints. Neighbors complaining about the different odors. Indoor air quality, more commercial applications, whether it's airports, museums, as well as commercial kitchens and some of the higher end hotels where they don't want those different food smells and odors. Emergency gas scrubbers, that can be whether they're used in municipal or industrial applications, but they're going to remove different toxic gases from the air in case of an accidental release. So whether it's chlorine gas, ammonia, or sulfur dioxide, if a plant's using chlorine gas, for an example, to purify, disinfect water, and they have a accidental release in one of the cylinders, these emergency systems will activate, neutralize the chlorine gas, and turn that media into a safe, harmless salt byproduct. And today we're going to talk about protection of mission critical electronics from failure. One market that I haven't shown on this slide is we are entering into the biogas market. So there will be some future information on that at a later date. So stay tuned. All right. So industry is affected by corrosion. So the effect of gases in a controlled environment can be destructive. Corrosion on circuit boards account for 30% of all equipment failures in industrial applications. Damage includes disruption of electrical current flow and loss of signal. And acid gases are the most harmful. So rapid changes in temperature and humidity will accelerate the corrosion. So here's just a few of the industries affected by it. So the areas in those, within those industries that require some type of chemical filtration due to corrosion. So like MCC, motor control centers, that's the room where all electric motors are in a central location, which is very critical for plant operation. You have the operator control rooms as well. That's a room in which an operator monitors the operations of the plant, as well as ensures that everything is properly working, like using computer controls. So, in most cases, millions and millions of dollars worth of equipment in these MCC rooms, different operator control rooms. So it's important that the air in those rooms is purified and clean to prevent any downtime or any corrosion. All right, for corrosion control. So, all right, just a few items I wanted to touch on. So relative humidity, that accelerates the corrosion caused by gaseous contaminants in an exponential manner. And also equally important is temperature. So temperature fluctuation dramatically affect relative humidity and often cause local condensation. Salinity, corrosion rates tend to increase when water conductivity increases. The higher the salinity, the higher the corrosion rate. And vapors, it is the gaseous product of evaporation. So vapor of some chemicals and some strong acids can cause corrosion. Dust is a universal contaminant, and it definitely, that can come from human skin, just over time, just causing dust, which could really cause some, equipment failures. So when the air quality does not fall within specified corrosion limits and other environmental factors such as temperature, humidity, etc., have all been ruled out, gas phase filtration or gas phase air filtration should be used to ensure we get those corrosion levels down. All right, types of corrosive contaminant gases. You have hydrogen sulfides, sulfur oxides, nitric oxides, etc. So acidic gases, that's any gas when dissolved in water will form an acidic solution. As examples, hydrogen sulfide, HCl, hydrogen fluoride, and sulfur oxides. So almost every one of the process industries and heavy manufacturing industries are plagued by corrosion on their process control equipment. So, I don't want to talk in absolutes, but there's pretty much 99% guaranteed you're going to have some type of corrosion in one of these heavy industries, potential corrosion. So common sources of corrosive gases. Here, as you can see, very common environments have corrosive gases. And this is just a very small list of hundreds of applications out there in the commercial and industrial environments. So I won't go through each one, but kind of gives you an idea what's there. All right. So problems and equipment damage from corrosion. So damage includes disruption of electrical current flow and loss of signal. So as the corrosion increases in thickness, the resistance decreases until functional shorting occurs. Studies show. I want to give an example as far as a paper, paper plant. So there's some studies that show that unplanned downtime on a single paper machine can cost over $20,000 a minute, and unplanned mill outage over $1 million a day. So it's really important to ensure that these systems don't go down, because that's a big price tag to take care of just for unplanned downtime. So minimizing that unplanned downtime is a challenge shared by all producers of pulp and paper in that particular application. So unplanned downtime kills profits and cripples commitments to your customers. So that would also affect oil and gas as well. All right. So the more conventional type of corrosion occurs when acid gases react with the metals themselves to form non-conductive salts. As the salt buildup occurs, the salt is forced back up through the pores of the metal onto the surface, thus causing a disruption in the contact point. Gold is one of the least reactive elements on the periodic table. It does not react with oxygen, so it never rusts or corrodes. But gold plating will not stop the substrate from corroding or oxidizing. This is because thin layers of the plated metals have small pores which allow for corrosion to propagate through. So in this slide here is showing systems with and without protection. Can give you an idea of kind of the damages of those corrosive gases being unchecked. All right, standard for air quality. So this was developed in 1985, so the ISA standard. The purpose of this standard is to classify airborne contaminants that may affect the process measurement and control instruments. A few notable companies were involved with this development. It was Honeywell, as well as Exxon, IBM, Hewlett Packard, and a host of other different companies. And also the RoHS compliant, and that's basically restrictions of use of certain hazardous substances in electrical and electronic equipment. So this is more of a European directive, and it's the first of many lead-free regulations that have been passed. So these regulations have resulted in increased sensitivity of printed circuit boards, hard disk drives, servers, etc. So increasing requirement of air quality monitoring in data centers. Many non-industrial environments that were considered benign with regards to corrosion of electronic equipment are experiencing serious problems as a direct result of RoHS compliance. So. All right, so in this, when it comes to the ISA standard, I would say areas are determined, have a G class attached to them to determine, the level of corrosion in that particular space or environment. So, and it's measured in angstroms. So in corrosion chemistry, an angstrom is used to measure corrosion rate, thickness of corrosion products, and oxide layers. And it is 1/10,000,000th of a meter, or 100 millionth of a centimeter. And it was named after Swedish physicist Anders Jonas Angstrom. So G1 is a mild environment for corrosion. So with the G1 environment, gas phase filtration is probably not necessary, and the environment is sufficient for operation. G2 is more of a moderate environment, but in some cases, gas phase filtration probably would be required just to ensure there's no unplanned downtime of the equipment. The G3 environment, very harsh, GX severe. In those environments, you have to have some type of gas phase filtration to bring those down to a G1 recommended. Yeah, G1 needs to be at G1 levels. All right, standard practices. So temperature, you have to make sure it should be maintained at the lowest temperature practical and consistent with personnel comfort and effective humidity control. So you want to keep it at ideal temperatures at 70 degrees Fahrenheit, 22 degrees Celsius, plus or minus 2 degrees or so. But the corrosion rate can double for each 10-degree change in temperature. So room pressurization for a sufficiently sealed room, this shall be achieved with approximately 3 air changes per hour. So keep that room pressurized. A minimum pressurization airflow of 5% of the room air volume per minute would be needed to achieve that. And recirculation airflow requirements shall range from 10 to 20% of the volume of the protected space, depending on the room sealing capability, level of traffic that's going in and out of the room. That could also, that people going in can also generate contaminants as well. And then as far as particulate, studies show that sodium chloride particles and ammonium sulfate particles strongly affects atmospheric corrosion rates of copper and zinc. So, you know, all of these items are carefully studied and analyzed when determining the best solution for gas phase filtration and corrosion control. So pressurization and air circulation, some of the basic designs. We look at each application individually or as a unique application, but what we will provide will depend on the construction of the room itself or the area. How old is the building? Is it airtight? Are there any air leaks or in the ducts or in the walls themselves? And also the relative humidity, which we wanted below 50%. A greater percentage in the temperature target of 70 degrees Fahrenheit and stable. So here's a basic room design where there's a pressurization unit, whether it's like a deep bed system or modular, bringing in the outside air. Then that purified air is connected, or what's the word I'm looking for? Fed into a heating, cooling, dehumidification unit or system. So that ensures that, the outside air, we want to control that relative humidity and that temperature. So clean air goes and gets conditioned before it's exhausted into the room or the protected space itself. And also in this application, there's another system, a recirculation unit, which is a power package filter unit that will further gas removal to ensure that room is gas free. We're getting the pressurization to keep any gases out, as well as recirculating the air inside the room. In this room design, we're actually bringing in the outside air in both, all outside air in this scenario, but we're just using a pressurization and recirculation system to help pressurize that room, but also clean the air as well. So depending on the room size and the contaminant levels, this may be a good option, good cost-effective option for gas phase. And then the last design here, where all of the systems are outside of the room itself. So all of the purification, pressurization is done outside of the room. So you bring in the outside air, purified, conditioned before it goes into the space, as well as recirculating the air and controlling that temperature, because as it leaves the building, it's going to be affected by the outside conditions. To condition that back into the recirculation unit, then back into the room. So a few different scenarios for that, but it's really just, again, we look at each project and application individually determine what's the best solution. So a comparison of the different chemical filter types, the deep bed systems, as I mentioned, for more heavy industrial applications, higher levels of odors, but you're going to have that 99.9% removal efficiency, even just for one pass of media. But the max velocity is 100 CF feet per minute, and the cost much more has a higher cost than the other solutions, but also has a longer media life. And you have our PP12s, our PurePack 12 modules, PP18s, more of our commercial applications, and then you have the matrix structured media filters that we would use in some applications to give you a good removal at a higher velocity. So, and lower cost, because you can the housings can be a lot smaller. So just, just depends on the applications and what's present. All right, air quality monitoring. So we, to really promote PureAir, we have a world-class laboratory for testing our medias and also doing a lot of research so that way we can come up with the best media formulations, for optimum gas removal. So we're constantly, hiring new experience and new talent to help us achieve those goals. So, and of course, the gas phase media will, has a finite life to it. So, and it's going to be based on whatever gas are present and also the amount of that gas. So, it's critical to have those, to have that laboratory that can help first develop the proper media for each application, as well as test that media to ensure the remaining media life, and also, conducting that quality control, quality analysis to ensure that every pellet of media that leaves our facility is of the highest quality. And quite frankly, that's just why we're the world leaders in the removal of odors, gases, and vapors. We put that work in, that time for that research to ensure, proper functioning and highly performing systems. All right. So the kind of back to the ISA standard as far as determining corrosion in a particular space. One way to identify the G level of a room is provide these different, let's say, corrosivity test kits or coupons that they can be placed in the room for 30 days, and they have a copper and silver strip. So once that's hung in the room for about 30 days or so, send that back to us for testing, and we can determine that corrosion level or that G level for the room, and then from there determine the best type of equipment to use. So environments that are higher than G1, we recommend some type of gas phase filtration on the inlet. It's very highly recommended. And here's what the corrosivity test kit looks like. You have a copper and silver strip. So once that information is filled out, we recommend just placing that in the room 30 days. And there will be instructions on how to send it back to PureAir for testing. And then once we receive the coupon is tested, we provide this report, to the customer, and that will provide that information as far as the, how corrosive the environment is, and then from there we can decide the best course of action. And also for air quality monitoring as well, we have the corrosivity test kits, but we also have electronic corrosivity monitor. So that has that continuously monitor the corrosion G level in a room to ensure it doesn't rise above that G1. So this room sensor is placed. This monitor is placed in the room, and it actually has the copper and silver sensors. So we're also measuring the humidity, the room pressure as well as the temperature. So have all that in one device, and that can be signal can be read back to the SCADA as well, so that can be monitored remotely. And we also have media testing as well. So at our laboratory, we can test the remaining media life, but we also have the different medias that change color as well as manual media bed indicators, which is shown here, as well as electronic bed monitors as well, so we can monitor the remaining media life and send them alarms remotely as well. So very useful and effective, especially in our municipal applications, but we're also using this for any deep bed system for industrial as well. Be a very, very useful tool for customers. Determine when it's time to change out the media before you receive any breakthrough. All right, so oil and gas applications. So I just want to highlight a few oil and gas applications in the Middle East that we worked on and are working on. Again, each project was unique in itself. So it's just only touched on just a couple applications. I think it's 3, but we have, I won't quite say hundreds of applications in oil and gas, but we have quite a few. So this is the KJO project in Saudi Arabia. So we worked on this one, and it was an oil, was a refinery on the border of Kuwait and Saudi Arabia, the Al Khafji joint operations. So, and they needed a solution to combat. They had very, very high levels of H2S. So this project was a joint operation between Saudi Aramco and the Kuwait National Petroleum Company. So they needed systems to protect their employees in case of a toxic gas release of H2S when they have to shelter in place. They also needed some systems to protect their electronics from corrosion. So the solution that we came up with, we gave them some side access housings, were modular units, as well as our deep bed system, which is a V-bang transition system. So the modular units were, have high airflow applications and lower gas levels. And the VTS, the deep bed system, with for high levels of contaminants. For this combination on the V-bang transition system, we use a combination of our hydrogen sulfide scavenger media, which is sulfosorb Fe. So it works great at very, very high levels of H2S, but it's more like a roughing filter. I call it a H2S punching bag. So it's going to take out, say, 90% of the H2S that's there. But then we also provided a polishing media as well, which is our PureAir 12. So that's going to polish any of the remaining H2S, as well as any other gases that may be present. So with this dual combination, it was quite effective, and it definitely just worked out where the H2S levels in essence have been dropped, to undetectable levels. So another project for us, this was the Lulu, we called the Lulu field development, and this was in Abu Dhabi. It's off the coast of Abu Dhabi, and it was actually 2 phases for this project, where they required pressurization on their offshore oil platforms. So we were actually successful in providing the gas phase filtration system chemical filter units for both phases, phase 1 and phase 2. And then this was a very time-consuming, very involved application, because the requirements were very stringent as far as the type of material required for the systems, the necessary paperwork, factory acceptance tests. So, to give you just a little background, these units, they were required to be very robust, where they were 3 millimeters, 316 L stainless steel, also marine coated with a special marine coating for that corrosive environment. The coating itself had almost 8 pages of specs to it. So, and also the units were all welded. And on top of that, they were also required to be ATEX certified as well. So the entire system had to be ATEX certified. That required us to bring in a company, I think it was called Bureau Veritas, to come in and certify each one of the units to ensure that everything was explosion proof and ready to go. So it took a lot of resources here at PureAir to, just for the paperwork alone for this project was very, very time consuming, and definitely an eye-opening experience for us. Definitely phase one had a few challenges that we were able to work through, but it really worked out well for us on phase two because we had that experience in providing these systems. And I will say that, to my knowledge, we're probably one company that can provide these 3mm 316 stainless steel systems, marine coated with the ATEX certification. I haven't seen too many companies provide that, but we were able to, and the system's actually working quite well. And here is just an actual photo in this slide showing what the units look like. Just kind of give you an idea with the redundant blower systems, very heavy duty, all the explosion proof controls as far as the lights inside the blower section, viewing windows. So very, very high. And this here is Lulu 2. Units were identical. Some were bigger than others, but kind of gives you an idea of the robustness, of these systems. And we are currently working on, we have in-house 2 the Marjan oil field that's in Saudi Arabia. So it's another oil and gas application on an oil platform off the Saudi Arabian coast. And so we currently have 2 projects we're working on now. Both are in the, Marjan 4, that's actually currently in-house for seven passive units. And it has 4 passes of the PurePack 12 cassettes filled with the self-absorbed 2 media. And these units aren't as robust as the Lulu project. So these are just 316 stainless steel units, but it has all 316 stainless steel components, and the units are also painted as well. So we just want to make sure they have that corrosion protection out in these high salt, you've been on the ocean, you have a lot of salt content in the air, so you want to make sure you have the proper protection for the systems themselves. Here's just a slide of what the units, in essence, will look like with the 4 passes of the media painted. And we also have another project, Marjan 10, that we have in-house now, but that's in the submittal stage at the moment. But that's actually going to be 10 deep bed systems or pack bed units, pack bed systems that we're going to provide. They're going to be double wall as well. So I just wanted to show a photo of what these systems will look like. So some of them will be much bigger, but it kind of gives you an idea of how the systems will look. And we work with the engineering company SciPim really for almost 2 years on this project before it finally came to fruition and became an order. So we're excited about providing this project for the Marjan oil fields, and there are also numerous other Marjan projects that are coming back on the radar as they were shelved due to the pandemic. So now we're starting to see them come back to life. So it's exciting, and we're looking forward to it. All right, solution scenarios. As I kind of mentioned before, the pressurization, you want to have that minimum airflow of 5% of the room volume to ensure we're keeping those gases out. And as far as recirculation, airflow requirements shall range from that 10 to 20% volume. So make sure that room, we're keeping track of the temperature, make sure we keep that temperature within range, as well as the humidity to ensure we don't create a environment for corrosion. All right, so PureAir filtration, the full solution. So as I mentioned previously, with our company, we have probably almost over 50 years experience, combined experience in providing gas phase solutions. So first we identified the problem, and we determined what's going to be the best option, best solution for that particular problem. As I mentioned, we have world-class laboratories. We're always constantly improving the company with the research and development to make sure we're always on that cutting edge and that forefront for the gas phase filtration. And also, we're probably the only company that can monitor the remaining life of the media as well as the environment for different applications as well. All right, considerations for creating that full solution. So we have, make the type and level of contaminants that'll let us know whether we can use a modular system or a deep bed, temperature and humidity, of course, then volume and frequency of airflow, the room size. Is the room occupied? There's a lot of people flow going through the room. And also, we need to also look at any particulate filtration at the inlet and outlet of each system to make sure we're capturing any dust, so that doesn't affect the absorbent media itself from performing properly. All right, so with that ends the webinar. And I want to know if you have any questions. Let me go out. Well, stop sharing. Let's see if there's any questions or no questions at the moment. Well, if there are no questions, I guess I will. Let's see. Nope. Yep. Okay. If there's no questions, I will go ahead and end the webinar. And thank you guys very much for attending, and we look forward to seeing you at the next one in December. All right. Everyone have a great day.